Hey everyone, welcome back to Brainstorm. This is Python for NCEA. Now, in this video, we're going to take a look at classes and objects. So let's get into it. So what are classes and objects? The way to think about classes and objects essentially is that a class is a blueprint for an object, and an object is an instance of a class. So again, we're using each of them to define each other. So how do we actually visualize this? You can think of a class as a blueprint for making different objects. Okay, so for example, let's think about a car. Okay, so the class is the car class. Okay, so essentially we have a whole bunch of different cars. We've got different brands, different colors, different engine sizes, different year models, for example. Okay, so the class is the car. So cars all have the same thing, right? So they all have a brand. They all have an engine size. They all have a seat capacity. They all have, they all have a different color, right? Now, an object is a very specific instance of that car. So for example, we could have a black Mazda. That black Mazda is still a car, so it's still part of the car class. It's just a very specific instance of that. Okay, so what we'll do is we'll dive in deeper into how we use classes and objects in Python. Okay, this is what we call object-oriented programming, because our programming is based around instances of classes or objects. Okay, so I remember when I was doing I didn't actually sit this internal in level 3 because I was doing scholarship, but I remember hearing that I think that the teacher thought that object-oriented programming was the same as like a graphical user interface, right? So while elements of like tk-enter, for example, they are objects, that's not strictly speaking object-oriented programming. It is an example of it, but it's not really classical object-oriented programming. So we'll take a look at what actually object-oriented programming is. Okay, so how do we set up a class? Well, we use the keyword class. So let's do the car example, for example. So we'll take the class and we'll call it whatever we want to call it. We usually use a capital letter, so we'll call it car. We'll put a colon here, and then inside of this here, we need to put what we call, we're going to write a whole bunch of functions, and those functions are what we call methods. Okay, we'll go over methods soon, but what we do first is we need to initialize the class. There's a very specific way that we do that, and you have to do this. So what we do is we write def for defining a function, we do 2 underscores, we write init for initializing, and then 2 more underscores, then we put parentheses and then a colon. What goes in here is everything that we want to pass into the car when we make that object. So for example, we might want to pass in the color of the car, the make of the car, and the year of the car, and let's go size of the car. So you can have like a sedan, you can have a hatchback, you can have an SUV, for example. The thing that we do in here is we need to write, so I've forgotten the most important thing. So these are all the things that we're going to pass in, but we always need to include something called self as the first parameter in any of our functions within the class. So self, SELF. This self here is going to refer to any object or any instance of the class when we use our methods. Okay, very confusing, I know. Just bear with me. Whenever we are referring to anything in our class, we need to use the keyword self. Okay, so these are just what we're passing in. We need to make our own variables within the class. So essentially, we're going to do almost the same thing, but we always need to start with self. So what we'll do is we'll write self dot. You can go self.color, but usually when we go through Y, we put 2 underscores, and then we put color, and we set that equal to color. The next thing we can do is self._make is equal to the make that we've specified. Self.__year is equal to year, and self.__size is equal to the size that was specified. Okay, so this is how we initialize the car class, right? So essentially what this means is that when we create a car object, we pass in, for example, we'll pass in the color, so we'll pass in like black, Mazda, 2014, and the size, so like hatchback or something. Okay, so all these variables are going to be passed in one after the other into what we say are the attributes of the class. Okay, so the self.color, self.make, self.year, self.size, these are the attributes of the car. Okay, so this is what makes the car a car. Anything that it defines the behavior or the attributes or the personality of that object or of the instance or object, we need to define it in our initializing step. Okay, don't worry about this. We'll go over it when we talk about creating objects. So we've just created a car class. Next thing we'll talk about is using what we call methods. You might recall that when we've worked with lists or strings, we've used things like, so this is my list is equal to 1, 2, 3, for example. Then we use something like mylist.sort and like mylist.reverse, for example. So this would make it 3, 2, 1. These are what we call methods because they have dot and then some function name. So what I'm saying here is that lists, strings, tuples, all those things, they are examples of classes, but they're already predefined. We've made our own class here. So when we write functions, they are actually what we call methods. So if we want to access functions inside of our objects, we have to use dot and then the name of whatever the method that we've created is called. There's very specific methods that we might want to include. Those are called getters and setters. Okay, so how do we use getters and setters? So we're going to write a new function. So every new function is considered a method when we're working with classes. So I'm saying functions here, but really we should be saying we're creating a method. So def, okay, and let's write a method which grabs the color or returns essentially all of these variables. Okay, so we're going to call them getters because we're there. We say get color. Okay, and because we're getting them, we don't need to include any parameters except for self. So remember I said whenever we write a method, we always need to include self. Put a colon there, and we just return self.__color. The reason we're doing this is essentially usually in objects we set it up so that you can't grab anything inside the init unless it's a method. Okay, so things inside the method using self can access those things. Okay, a bit confusing. Just bear with me. Essentially, we need to use getters and setters to access anything inside of that we've defined in our init. Okay, so that's going to get the color. That's going to return the color specifically. We can write a whole bunch more. So we'll write 3 more for getting the make, the year, and the size. So get make takes self. We return self.__ make. I'll copy and paste this and do the same for the last 2, which is year and size. Get year and get size. So let's return self.year and self.size. Okay, so I think I better go through making an object so that I can talk about setters. So when we make an object, we first we'll assign it to a variable. So let's create a variable called Mazda. Let's set it equal to, and then what we do is we write the name of the class, which is car. We put our parentheses, and then similar to how we do a function, but we just pass in the variables that we need to do. So remember, self is automatically included, so we just consider everything else that's not self. So we're passing in the color, black, the make, Mazda, the year, 2014, and the size. The size is a hatchback, for example. You can make it anything you want, right? It could be any car you want. It could be a Honda, it could be a VW, it could be a Toyota, doesn't matter, right? So we've just created an object. Okay, so this is an instance or one example of the car class. If I print Mazda and I run it, you'll see that it's created a car object. Okay, but we can't actually see what that object is. It's a bunch of code, right? So if we want to access elements of our car class, we need to use our getters in order to access them. So remember that we've created methods. So when we want to access methods, we need to use dot and then whatever the method is. So got get color is the first one. So get color, and there's nothing passed into it, just self, but self does not need to be included in here. So if I save that and click F5, this should print the color of this very specific Mazda object. So you can see it prints out black. If I print, let's say I want to print the make, the year, and then the size, well, it prints out all the attributes of our car. Okay. If I make another object that's not a Mazda, let's make a Honda. So car is a red, the make is a Honda, and these are variable names, so we can make this whatever we want. Let's say the year is 1995, and it's a sedan. Okay, so if I print this now, but change all of this to Honda, then it's going to hopefully print out all the specifications for the Honda car that we've just created. So as you can see, even though these are kind of different objects, we can still use the same blueprint to make them, right? So if we save that and run it, you'll see that, okay, this is for the Mazda and this is for the Honda. Now, if I print Mazda and Honda, you'll see that they are still car objects, but they're located at different locations because they're different instances of the car class. Okay, so they're totally different things, but they're made from the car class, if that makes sense. So let's talk about setters now. So what we want to do is what happens if we made a mistake, for example, and we want to change, or like we got into a crash, and we need to then change the car color. So change the car color to green, for example. I don't know why you would do that, but so what we'll do is we'd use something called setters. So we'd say def set color, and what we need to do, we obviously need to pass in self, and then we want to pass in the color that we want to change it to. So we'll call that color, or maybe we'll call it new color, and then all we do is we say self dot underscore underscore color, which is what we've defined up here, is equal to the new color. Okay, so now let's do it on the Honda, for example. Let's say that the Honda got into a bad accident and we change the color to green. So we're going to print all the information there. So let me just comment out all the stuff about the Mazda to make it, whoops, what have I done? Comment all the stuff out about the Mazda. Let's actually change the color of that Honda now. So Honda dot set color, and because we need to pass in the new color, so we're passing the color in the brackets here. Let's call it green. And now if I print all of the attributes, we should see that it changes from red to green. So if I run that, see that the objects, you'll see that they're actually different locations. Don't worry about that too much. They are just different objects. That's the main thing. So essentially we had a red Honda. Now we have a green Honda. Okay, it's still the same object, but we've changed some of the attributes about it. Okay, we obviously want to use setters where it makes sense. So we obviously can't change the year or the make or the size of the car. Okay, so maybe color is the only one that makes sense in this instance. Okay, so now we've looked at all about classes and objects. Let's move on to an application question. Now this question should be very similar to what you might do in your internals. I wanted to create a similar program that you would use. Obviously doesn't have any of the error handling or anything like that, but this is the basis of what you would need to do. There's not going to be any extra code or anything like that. So this should be like the core of a similar program that you would write. And then you can include the error handling and stuff through the videos that I've made prior. Okay, question 1. Create a class called student. The student class should have the following attributes: student ID, first name, last name, subject list, and the grade dict. Note that when student is created, the grade dictionary is not passed in. The grade dictionary consists of key value pairs, where the key is the ith subject a student takes, and the value is a list of tuples. Each tuple consists of the standard number and grade. Note that when setting up the grade dictionary, the list should be empty initially. Next, create getter methods for all attributes of the student class. Finally, create a method called addGrade. Okay, and these are all the parameters that we need to pass. This method adds a standard and grade into the grade dictionary where the key is the subject. This is our example input. So we're going to create a student, we'll get all the information, we'll add a grade, and then we'll print the student dict. This is what the output should look like. So ID, first name, last name, the list of subjects. Okay, we'll add a grade and then we'll print the grade dictionary. Okay, so you can see we've added a grade for calculus. This is the standard, this is the grade, and this has been added as a tuple into the calculus key. So the calculus is the key. It's been added into its list as part of the grade dictionary for that specific student. Okay, so this is just the input I've just repeated down here. So we need to create a class called student. Okay, class student. We then need to obviously initialize our class. So we'll do def underscore init underscore self. Okay, remember we always pass in self. Student class should have the following attributes. So we need to pass in a student ID, a first name, a last name, a subject list, and the grade dictionary is not initially passed in. Okay, so we don't need to pass that in. Then we're going to just initialize them. So we'll say self dot underscore student. We'll just call it ID for short. Self dot underscore. Why not? Well, why not call the student ID is equal to student ID. Self dot underscore first name is equal to first name. Self dot underscore last name is equal to last name, and self dot underscore subject list is equal to subject list. So this is just setting everything that we've passed in equal to an attribute of that specific student class. The last thing we need to do is pass in the grade dict that we haven't passed in here, but we still need to define it for each student. So the grade dictionary, I think that's what we've called it, grade dictionary, is equal to initially an empty dictionary. What we want to do, so the grade dictionary consists of key value pairs. So essentially we need to now use a for loop to set up our grade dictionary. So the key is the ith subject, and the value is a list of tuples. So the list should be an empty initially, sorry. So the way that we're going to do this is we've got our dictionary now. So what we'll say is for I in subject list. So we'll loop through the subject list and add it into our grade dictionary. So we'll say self dot underscore grade dictionary at I is equal to an empty list. Okay, and what I'll do is I will just print that grade dictionary just to make sure that it's being completed correctly. Okay, so we should get some errors here from here on because we haven't done that part yet, but this defines the student. So the student's called Jackson, and hopefully it should just print out that grade dictionary first. And as you can see, it looks like it's printing it correctly. Yep, so that looks good. So we'll just remove that print statement. So it looks like we're set up everything that we need to set up correctly. So we've created the grade dictionary. We need to create a getter method for all attributes of the student class. So that's going to be quite a bit of work, a lot of copy and paste, but no worries. So def get student ID, we pass in self, and that is all. We're just going to return self dot underscore student ID. We're going to do the exact same thing for, I think, all of the attributes. So we're going to have to do this 1, 2, 3, 4, 5 times. So that's 1, 2, 3, 4, 5. So we've got the student ID. We want to grab the first name. We want to grab the last name. We need to return the relative attributes. So we need to return first name. We need to return the last name. Get the subject list. So we need to return self.subject list. And then we need to lastly return the grade dictionary. So get underscore grade underscore dictionary. And then we will return self.underscore grade dictionary. Okay, so if I save that, now we've get student ID, get first name, get last name, get subject list, get grade dictionary. So here, I'm just using the getters and printing out what this returns. So we should be able to run the program all the way up until here, okay, because we haven't defined the add grade method yet. So if we run this here, as you can see, it looks like we've got most of the output that we need. So that looks good. The next thing we need to do is we need to create a method called add grade. So we're going to write a new function, which is called add grade. It takes in the parameters self, subject, standard, grade. All right. The method adds the standard and grade into the grade dictionary, where the key is the subject. So the subject's always going to be here. Okay, so we've already defined the subject. So all we're going to say is self.__ grade dictionary. So if I want, I could use the method here, but why would I do that? I could just access the dictionary quickly. So self.__ grade dictionary at index subject. So this will access the list for that given subject. And I want to append a tuple to it. So I want to append a tuple, which is going to add the standard and grade to it, right? So we're going to append the standard and the grade. Okay, I think that should work. All right, so if I save this and run it, well, as you can see, it's appended that standard to the calculus subject, which is what we wanted. And as you can see, it looks like it's identical to the output here. So it looks like that part of the question is complete. So what we have is something which can grab, which creates a student, and then we can add grades to it. If you wanted to implement this properly, you would probably need to have setters for creating a subject, for changing students' names and lists and all the jazz, and potentially changing grades as well if they still do resubs. I don't know, but that will suffice for this just here. Okay, question 2. Now we want to create a new class called class role. The class role class should have the following attributes: tutor teacher name, classroom number, student list. Next, create getters for all attributes and a setter for the teacher. Create a method called add students, and this adds the student. So this method takes an instance of the student class or a student object and appends them to the student list. Create a method called remove student, and this method removes a student from the list. So here's our example input. We're going to create a programming class which takes this guy called Mr. Pascal, that's our teacher. We're going to add a bunch of students. We've got a student called student1 here. Now that student is actually the homie Jackson. Okay, so it's going to add Jackson, and it's going to add a whole bunch of new students. And then what we're going to do is we're going to loop through. We're going to print all the students because they're all objects essentially. I'll go through very specifically why we have to do it like this and use methods. And then we're going to remove 2 students and print it again. Print them out again. Okay, so this is what the suggested output looks like. We've got all the students. We're going to remove 2 students, and then we've got we're left over with just 4 students. Okay, this is our example input, so we'll comment that out so we're able to use it. So, class. So we're going to create a class called class role. We're going to need to initialize that class, which takes self by default. We need to take the tutor teacher name, so we'll call that teacher name. It needs to take the class number and the student list. So student list will be passed in. Then we're going to use self.__ teacher name is equal to teacher name, and self.__ class number is equal to class number, and self.__ student list is equal to the student list here. Okay, I can actually call these anything, by the way. I just want to call it the same, just to keep it easy. So we've just defined our class role here. Okay, so this will generate the programming class, right? So this line should run here just fine. Okay, so if I was to print programming class, it should just print the like bytecode or whatever it is. So saying that we've got an object at this location here, and then nothing else will run because we haven't defined any getters or setters, which is what we're going to do right now. So we need to create getters first. So let's create a whole bunch of getters. So def get teacher name. We need to pass it self. So we'll return self.__ teacher name. We're going to do this for the class number and the student list. Okay, so we need to get the classroom number, and we need to get the student list. Okay, and we need to change this respectively, so self.classroom number and self.student list. Okay, so classes quite tedious, to be honest, to set up, but they are very useful when we want to have duplicate objects. Okay, so we've created all our getters. We also need to create a setter for the teacher. So, you know, as you know, teachers always seem to come and go, so we need to maybe change the name of the teacher or change it to a different teacher. So we'll set the teacher name, and we'll take self and teacher name. And what we'll do is we'll change self.__ teacher name to be equal to the new teacher name that we've created. Okay, so if we print, let's just check that everything is working here. So we'll print these methods. So get teacher name, where we'll get the classroom number, and we'll get the student list, which should be an empty list. Number, and get student list. We save that and run it, and get classroom number. This should be class number here. Okay, sorry about that. So what you can see is that we're getting Mr. Pascal, 13S10, and then the student list. So this seems to be generating the correct class. So that's good. Next thing we want to do is we want to be able to add students, and these need to be of the student class, which we've defined as this class here. Okay, so we need to create a new method called def add student. We'll take self and then the student, I believe. Yeah, and this method takes an instant of the student class, so a student object, and appends it to the student list. So quite easy. We're just going to append the student to the student list. So append student, which is the student object, to that list. Okay, so you can see that when we're calling add student method, we are creating student, we're creating a whole bunch of student objects or instances of the student class. Okay, so this is all what we've defined in the previous question. Up here, I will uncomment this line here just so we can create student one. Alright, so if I run this now, okay, what you can see is that we've added all these students here. Okay, so this is all about the programming class specifically, but then we've added all our students. Okay, and then what we've done was I've looped through the student list, and because each value in the student list, okay, let me actually print the student list just so you can see. So I'll just print I first with an end of equals nothing. Okay, so we're printing, so you can see that each value of I is actually a student object. So I need to use methods to be able to get the actual information out of that object. All right, so I can delete this now. So hopefully you can see that these are all student objects, and each student will, for example, have their own student dict, right? So they have their own grade dictionary, they have their own subject list. So now you can see that using classes and combining classes is very useful for our internals. For example, I can create methods now which are able to, within that class role, access a subject, access a student's subjects, add to their subjects, remove from their subjects, edit their subjects, add grades, remove grades. We're pretty much creating a full-on, I actually forgot what it's called, the role program, KMA. So we're pretty much creating a KMA in Python. Okay, maybe a lower level one though. So what have we done? We've created the add student method. So the last thing we need to do now is create a method called remove student, which removes the student from the student list. This is pretty arbitrary. So def remove student, we're going to take self, and what are we going to use to remove the student? We need to remove them based on the student ID. So we'll take the student ID. What we're going to do is we're going to loop through the student list. If the student ID matches, we're going to pop them from the student list. Because we're just popping one element, we probably could pop in going forward, but we're going to do it in reverse because that's how I've always taught you. Okay, so what we're going to say is for I in range, the length of self.__student list -1, -1, -1. So this is going to loop backwards. We're going to check if, so each of these is the index of self.student list. So we'll say self._student list at index I. What this is here is this is a specific student. We want to grab the student ID. So if you remember from before, the student, we have the method get student ID. So that's a getter. Get student ID. Yeah. So we're going to use that on the student object here. So get student ID. So this should return the student ID of this very specific student within the list. So we'll say if the ID here is equal to the one that was passed in the method. So if that's equal to student ID, we're just going to pop them from that list. So self._student list.pop at index I. So that should remove them from the list. So we're removing them based on their student ID. So if we've done it right, that should remove Jess and it should remove Habib. Okay. So save that and run it. You should see that it's removed Jess and it's removed Habib. Okay. So it looks like that our remove student and add student classes are working correctly. I'll just remove these print statements here just so we can get the exact same output as the suggested output here. Okay, and that pretty much wraps up classes and objects. Okay, so obviously I've gone a bit fast, but to be honest, I don't believe really anyone's going to be probably using classes and objects unless they want to make their internals a lot easier, a lot simpler. So I remember I did pretty much something identical in year 12. This and the other class is pretty much the whole program, right? We add some more getters and setters and methods, okay, and that's pretty much the whole thing. When I wrote it for level 2, I didn't really have a good understanding of Python. It took me ages, right? There was a massive program, super untidy, okay, but you can see that we've honed in pretty much everything that we've learned over the past, 13 videos. And we've combined it into a program which isn't even really that large, okay? It's quite modular in that sense, right? So this is where all the bulk of the adding is done. Okay, and then we're just repeating things by using our classes and our methods, okay? So that wraps it up for Python for NCEA. I hope you've enjoyed the series. I'm going to probably move back to more math-based standards from now on, because this took me ages to do. So I'll probably move back to level 2 algebra, or I might do calculus or probability, I'm not too sure. But I hope you enjoyed. Leave a like, and best of luck with your internals. Cheers.